So welcome to all of you. The last time we have seen what do we mean by a function. We have seen some types of the function. We'll continue for that. Okay. So we'll see one more the types of the function. So there are four types of the function. What? One function. One function. Then many one function. Many one function. Into function. Into function and onto function. Okay, so these four types are very important here. So that means what, if you consider a function, then what, it holds the two types of the function. Always it is two types of the function. Now first we will see what do we mean by one function. So suppose this is a function. Suppose this is what, a to b, and this is a function f. So this is what, a b c d e f, 1 2 3 4 5 6 1 1, that means 1 goes to 1. So suppose if you like this, if you do this, okay, so this so now this will be the function. Is it a function? Yes. So only one is related to only one element, so this is a function. So now we need to draw like this one, please. Suppose this is what, a and b. So this is what, f. This is what, a b c d e, 1 2 3 4 5 6, suppose. And if you like, if you give the images to like this is also a function. But now see here, so what do we mean by first one function? 1 goes to 1, right? So that means what, a function. So definition, a function f from x to y is called one function if for x y belongs to x y belongs to, there are two belongs, x not equal to y. So what, this is for if for all x y belongs to x not equal to y, implies that f of x not equal to f of y. F of x not equal to f of y. That means what, distinct elements have distinct image. Okay, distinct elements have distinct image. That means if a and b are from the domain, then they are distinct. Now a is not equal to b, then image of a and image of b are also distinct. Then such a function is one function. Now here what, image of c here, image of, so that means here also you can check that. So no element in B which has two or more than two pre-images, right? So that means what, the elements of B here, domain, codomain. So if it has if there exists at least one element such way that it has two or more pre-images, then that function will not be one function. Okay. So now here what we see here, no two elements have the same image. So this function is the one function. So this function is one function. Okay. Now this is not one function because there exists a and b. So they have the same image. A not equal to b. So here what, a not equal to b, but f of a is same as f of b. So whenever a not equal to b, your images also should be different, right? Image should be different. That means a not equal to b, f of a should not be equal to f of b. But here what, image of a and b are same, so this is not one function. So this is not one function. This is not one function. This is not one function. This is the one function. I hope that you understand the definition of the one function now. Now then we will go to many one function. Many one function. Now a function f from x to y is called many one function. That are many. So here what, many one function if for all x y, x not equal to y, but f of x is equal to y. So there exists, if there exists there exists x y such that x not equal to y. That means what? There exists at least two elements in x such that x not equal to y, but f of x is equal to f of y. But f of x is equal to f of y. That means what? There should exist at least two elements in a domain. Their images are the same, such that their images are same. So that means what? Here, suppose this is A, suppose this is B. This is 1, 2, 3, 4, 5, 6. A, B, C, D, E, F. Many goes to 1, right? So that means what? Many goes to 1 here like this, right? So now, so this is what? Many one function. This is what? Many one function. Many one function. Now if you draw like this, what? Suppose this is A, this is B. 1, 2, 3, 4, 5, 6. A, B, C, D, E, F. Suppose like this. Huh? So now this is not many one function because this should be the function. Everywhere there is a single arrow. So this is the function. Now this is not many one function. This is not many one function. Not many one function. Because what? Here there does not exist at least two elements which have the same image. Right? So that means this is not a many one function. This will be the many one function now. Okay. So now, if you want to see the example for many one function, suppose if I define f of x is equal to sin x now, right? So your f from R to R now. Okay. So now see here, is it 1 1 or it is many one? Okay. Now see here, sin 0 is 0, and this is same as sin pi. This is same as sin of minus pi and sin 2 pi and so on. Okay. So dot dot dot. This is same as what? Sin of 2 pi also. This is same as sin of 3 pi also. Right? So that means this is what? This is many one function. Many one function. This is many one function. That means your sine function, cos function, they are the many one functions. Okay? So this is not a one function. Okay? That means what? Function is either one or many one. If it is not one, then it is many one. If it is not many one, then it is one. Okay, so that means what? One of these is old, right? So that means what? The function is either one or many one. That means if it is not one, this must be many one. If it is not many one, it must be one. Okay. Now we will see what do we mean by into function and onto function. So into function and onto function. So we define this, right? A function f from x to y is called into function if there exists y belongs to y such that there exists y belongs to y such that there does not exist x belongs to x. There does not exist x belongs to x such that f of x is equal to y. Okay, so such that is repeated. So instead of such that we will see so that there does not any x belongs to x as f of x is equal to y. Okay, so that means what? That is there exists y belongs to y such that y has no pre-image in x. Pre-image in x. Pre-image in x. That means what here? So we draw the Venn diagram so that you will understand this part. So this is what? Suppose this is A. Suppose this is B. This is your function. 1, 2, 3, 4, 5, 6. Suppose and this is what A, B, C, D, E, F. Okay, so if you draw like this, okay, now this is a function. So now there exists F. So there exists F belongs to B. F belongs to B such that F has no pre-image in A. It has no pre-image in A, right? So now if you consider this, okay, so if you consider this 1, 2, 3, 4, 5, A, B, C, suppose A, B, C, and if you draw like this suppose, right? This is a function. This is the function, but this is not a into function. This is not into function. This is not into function. Okay, so that means what here? See here, there does not exist any element in B which has no pre-image, right? Every element has a pre-image. That means this is not an into function. Okay, so we will define onto function now. Define onto function. Onto function. Onto function. Okay. So a function, we'll write a definition. A function f from x to y, a function f from x to y is called onto function if the range of f is equal to same as the codomain. Range of f is same as codomain. That means every element of y has at least one pre-image in x. That is what? That is every element. This is verbal form. This definition is enough now. Okay. So I am just writing the meaning of this one. Every element of y has at least one pre-image. In x. This is the verbal form. Just with the question asked in the exam, just write only this: a function f from x to y is called onto function if range of f is same as the codomain. Okay, that means every element has a pre-image. Okay, so that means what? The function either into or onto. If it is not into, it must be onto. If it is onto, then it must be. If it is not onto, then it must be into. That means what? There are four types of the function. F is 1, 1 and into. Then what? F is 1, 1, 1, 1 and onto. Because what? If it is not into, it is onto, right? So now if it is not 1, 1 now, so f is what? Many one or anyone into. Many one and into. So f is what? F is many one and if it is not on into, then it is what? Onto, right? So that means what? If you take any function, it is one of the so it is one of the type. That means what? If it is 1, 1 and onto, or it is 1, 1 and onto, or it is many one and into, or it is many one and onto function, right? So that means what? One of the exists. If it is function, then one of these things is only one exists, not two now. Only one, right? So now, if a function is 1, 1 and onto, both 1, 1 and onto, see what happened. Suppose we consider the function, it is 1, 1 and it is also onto. Okay, so that means okay. So that f from x to y, which is 1, 1 and onto. Okay, so we'll write the x now. It is 1, 1 means what? Number of element x and number of element y are same now here, but x and this is y. So 1, 2, 3, 4, 5. A, B, C, D, E. Suppose your images are like this. This is. So this is what 1, 1 and on 2. This is what 1, 1 and on 2. Because what? So distinct element have distinct images. That means what? These are what? So everywhere there is a single arrow. Here also there is a single arrow. That function is always 1, 1 and on 2. If you reverse this, that means what? If you write here y and if you write here x now, this is your f inverse. Then we'll just check f inverse. Okay, so this is f. So what happened? This is what a, b, c, d, e. So this is what 1, 2, 3, 4, 5. What is the image of 1 here then? Image of a will be what? 2 now. Image of b will be 1. Image of b will be 1. Image of c is what? 5. Image of c is 5. Just we are reversing that. So image of c. Image of d will be what? 4. Image of d will be 4. Image of e is what? 3. Image of b is 3. Now see here. See here. This is also what? If you reverse this is also 1, 1 and on 2. This is also 1, 1 and on 2. Right? So if you take other function, many one. So if you take the many one function, okay, we'll take the many one function. Take many one function. 1, 2, 3, 4, 5. A, B, C, D. Many one and into function. We'll take many one and into function. Okay. So many means what? Many goes to 1 now here. Okay. So I will take this. Now this function is what? This function is many one and into. Because what? D has no prefix. That means this is many one and into. Now if you reverse this, suppose this is your x, suppose this is y. Now this will be your x and this will be your y. This will. So this is what? A, B, C, D here, and 1, 2, 3, 4, 5. What is the image of A? Image of A are 1 and 2. Okay. Image of B is 3 now. Image of C is what? 4 and 5. Image of C is what? 4 and 5. And D has no image. So now this is not a function. This is not. This is what? This is what? Many one. Okay. This is many one. This is many one and into function. Many one and into function. Okay. So now this is not function then. If you reverse this, then it will not function. This is not function. This is not function. So that means what? If you take f as 1, 1, 1, 1 and into 1, 1 and into. And if you reverse this, into means what? Into means what then? If you reverse this, then it will not have the image then. It will not, if you reverse this, then it will not function. That means what here? So here what then? F is if you reverse this, it will be not a function then. Okay. So now if you take f from 1, 1 and onto just we are seeing, if you take 1, 1 and onto, then if you reverse this, it will be the function then. If you take many one and into, so this function is many one and into. If you reverse this, it will not a function. Okay. If you take other function, so this is third one. If you take many one and onto now, onto means everywhere image, but many one now. This is what? Many one. Suppose if you write this, what 5? So 5 will not function. Suppose now 6 will be here. Suppose. Okay. Now then what? Image of D will be what? Image of D will be the 6 now. Okay. Now this is what? Many one and onto now. This is what? Many one and onto function now. And if you reverse this, so what happened then? So again, if you reverse this, A has 2 images. It will not a function then, right? So that means what? If you reverse this, many one and onto function, if you reverse this, then what here? One has 2 images. So again, that will be not a function. That means what? If only for 1, 1 and onto, if you reverse this, it will be the function. For other, it will be not a function, right? So that means what? We are interested in 1, 1 and onto function, right? So that function, if function is both 1, 1 and onto, you know that the inverse is exist, and this is called bijective function. It is called bijective function, and you know that inverse of the function is exist if and only it is 1, 1 and onto. So note, we'll write note. Let f from x to y be a function, be a function. Okay, we write note 1. If f is 1 1, f is 1 1 function, then f 1 1 function, then it is also called as, it is also called as, also called as injective function. We will write, so just we will write a 1 1 function, f, okay, we will write if f is 1 1 function, then it is also called as injective function. That means 1 1 function is also called injective function. Second, if f is onto function, then it is also called as surjective function. Surjective is onto function, surjective function. So use one of the words, it is onto or surjective. Okay. Now we will write the definition. Bijective function. Definition. A function f from x to y is called a bijective function if it is both 1 1, and onto, right? So we also call it is both injective and surjective. That is if it is both injective and surjective. Use only one of these, what? Both 1 1 and onto, or both injective and surjective. Okay. So this is these two words are new for you, right? So these words are, you are familiar with 1 1 and onto, so you are not familiar for this one. But now here what? Afterward we are using injective and surjective function. That means what? A function which is in both injective and surjective is a bijective function. So if you want to show that it is bijective function, just show that it is injective function and it is surjective function. Okay. So now composition of two functions. Two functions. Okay. So definition. Let f from x to y and g from y to z z should be the capital, y to z be the two functions. Then the composition of f and g is a function it is denoted by like this, from x to z, defined by g compose f of x is equal to g of f of x belongs to x. This is true for all x belongs to x. This is the definition of the composition function, right? Now see here, f from x to y. So f from what here? X to y, and g from what? Y to z. Now y to z. So here what? So if g compose f of x here. What is the definition? G of f of x. G of f of x. And where is your x? X belong to x now. Okay, this is true for all x belong to. Now see, once you apply f on the element of x, see your domain of G compose f. Domain of G compose f is what? Domain of this is what? X to z. How you got this? How you got this? Now this is what? This x is the element of x. So you are applying on f on the x. So the x should be in the domain of x. So your domain of x is what? Domain of x is this. Or domain of f is what? Capital X. Your x is in the. So you can apply f on the elements of the x, because when you can apply the function, you can apply your function only on its domain, only on the elements of its domain. So if you apply on f, you can apply f on only on the elements of the domain. So if you want to apply f on the x, so x should be in the domain of f. So what is your domain of f? Is x now. Okay, so that means f of x is defined now. This is defined. So when we apply f on the elements of a capital X, then this element is in the codomain. So f of x is the element of the codomain. Now you are applying g. When you can apply g, so you can apply g only on the elements of y. So that means this f of x should be the elements of y. Yes, the f of x is the elements of y. So this is the elements of y. Okay, if you are applying g on elements of y, then g of something will be the elements of the codomain. So this g of f of x is the element of the codomain. So therefore this is the codomain of the g compose f is what? Z, and domain of the g compose f is on x. So if you want to define this, see, suppose this you want to define this, whether is it defined or not, that we will see now. This is by definition, this is what? G of x, and this what you are applying g, that means this x must be in the domain of g. So x must be. So what is the domain of g? This is y. So g should be this x should be in the y, because what? If it is not in the y, you cannot apply g on the on that element. Right? You can apply g only on the elements of y, because domain of g is your y. Okay. So now here what? So once you apply g on the elements of y, then its element is enter in the codomain of the g. So that means this is the element of z now. Now what you have to apply? F. So can you apply f? You can apply f only on the elements of x. So this is not an element of x now. G of x is the element of z. It is not an element of x. That means what here? F compose g is not defined. It is not defined, because what? Your g of x is not an element of x. So that means it is not defined. So you will redefine now this. Suppose for the composition. Now see which composition exists then. Okay, suppose this is what? F from x to y, and your g from y to z. This is domain and y to x now. Instead of z, I will take y to x now. Okay, now can you define this g compose f? Okay, suppose this is f. By definition, this is what? G of f of x. G of f. You are applying x. You are applying f on x now. So this x should be in the domain of f. So this is true. What is the domain of f? Is capital X. So if you want to define this g compose f of x, so this is what? By definition, this is g of x. Now here what? You are applying g on the x. So can you apply g on the x? So if you want to apply g on the element on x, so x should be in the domain of g. So what is the domain of g? Is y. So here this x should be in the y. So whether these two are well defined or not, that we will see. Okay. So now see here. What is this element? So this is what? F of x. So x is the element of x now. Now f of x is the element of y. Can you apply g on the elements of y? See, the domain of g is y. You can apply g on the elements of y. So here what then? So here what? G compose f is defined, because what? You can apply g on the elements of y. F of x is the element of y. So that means what? Here what? Your x is in the domain is this, right? G compose f, because you are applying x should be the x now. Now then g of this, right? So if you apply g on this, that means what? This is what? Capital X, because what? G of f of x is the element of the codomain of g. What is the codomain of g? Is x. That means what? G compose f is from x to x. It is well defined. Is defined. Is define. Okay, so now here we will see now. So what is this? This is your x. X is the element of y. Must be element of y. Okay, no problem. So we'll take the choice of we'll take the x as a domain of the in the domain of the G. Now we have taken this. Okay, so now your G of x is well defined now here. No problem for this because we have taken x from the element of y, not from the capital X, not from the x. That means what this is. That means your G of x is well defined here. Now G of x. So this is what domain of the G is y. So G of x is the element of x now because what G of x is the element of its codomain. So your G of x is the element of capital X now. Now we have to apply f. Now G of x is the element of x now. So can you apply f on the elements of x? Yes. What is the domain of x? Domain of f is x. So G of x is a member of x. So you can apply f on the elements of x. So that means what here f compose G is what your y. So now here what this is the element of x now. You are applying f on the elements of x. Then this will what? So f of the elements of x is nothing but in the domain of the in the codomain of the f. So what is the codomain of the y? So this is y. So that means what is defined. That means what here your domain and codomain are interchanged. Then both the compositions are exist. Now here what f from x to y and g from y to z here. So here y to capital Z. So here what f compose G, whether it is defined, we'll check this. This is what f of G of x. So where is this said? X must be in the domain of G. Your domain of G is what here? Y. So now see here, see G of x is the element of Z, right? And you are applying it. Can you apply it on the? So this is not defined, right? So this is not defined. Now see G compose F now. So this is what G of f of x. So this is what G of f of x. Okay. So now where x should be in the domain of f. So what is your domain of f? Domain of f is x now. Now this f of x is the element of y. Can you apply G? Yes, you can apply G because G is the element. G is what? Domain of G is y. So this f of x is the element of y. You can apply G on the elements of y. If you apply G on the elements of y, then what this part is what this. So this is what defined. So this is defined, and this is the function G compose f is a function from. So what is here? Domain of. So here see what is G compose f. The domain of f. Domain of f is what x. And what is the codomain? Codomain of G. So codomain of J is Z. So that means what G compose f is a function from x to z. And here what f compose is x to y, y to z. Your f composite does not exist, so it is not defined. So these are the types of the functions. Okay, so now we'll see invertible function now. Inverse of a function. Inverse of a function. No problem. Let f be a function. Let f be a function. Okay, whatever this the function. Okay, G is said to be inverse of a function f. Inverse of a function f if there exists. G is said to be a inverse of function of f. Inverse function. Inverse of f of inverse function of f. Inverse function of f if G compose f and f compose G are identity functions. Identity functions are identity functions. Both are the identity functions. Okay, so that means what? Note. If f from x to y is 1 1 and onto 1 1 and onto, that is f is bijective. If f is bijective, then f is said to be invertible function. F is said to be invertible function. Okay, so these are the types of the functions. Okay, so we have to take the problems on the types of the function. Okay, so only the problems are remains. So I hope that you understand all the types of the function. Okay, so in the next lecture, so in the next video lectures, we will see some problems on the functions, right? So now we will stop here.